Hi everyone, and welcome to our review of exponent rules. The first concept we're going to review in terms of exponent rules has to deal with multiplication. Here we see x cubed times x squared. Both bases are the same, but they have different exponents. Well, what does it mean to take a variable to an exponent, or any term for that matter? If something is squared, we know that we're multiplying it by itself. There are two x's. If I had x to the fourth, I would be multiplying it by itself 4 times. So if you look here, we have an x cubed. X times x times x. And those x's are being multiplied by x squared. So another x times x. How many total x's do we have now? There are 5, which is the simplified version of x cubed times x squared. Now, with such small exponents as 3 and 2, this process wasn't that difficult. But if these exponents became much larger, this process would be way too cumbersome. Therefore, we have a rule when multiplying bases with different exponents. I take the exponents and I simply add them together. So, x to the power of 3 plus 2 gives us the correct answer, which is x to the 5th. Take a minute and write down what you think the answers to these problems are. Okay, so as we discussed, when multiplying the same base with different exponents, we are adding the exponents together and leaving the base as it is. 5 squared times 5 to the 4th becomes 5 to the power of 2 plus 4, or 5 to the 6th power. Now here the base is a. Which numbers should I add together for this problem? Well, I can clearly see that there's a 3 here. If there's an a with no visible exponent, the exponent is a 1, a to the 1st power. So now I'll take these exponents, 1 and 3, add them together, and the answer is a to the 4th. The next exponent rule we're going to discuss are powers of powers. So you see that we have x squared inside the parentheses, and this term is going to be cubed. So this means I am multiplying x squared times itself 3 times. X squared times x squared times x squared. And what does x squared mean? Well, we know that x squared means x times itself, or x times x. And this is multiplied by itself 3 times. When we're multiplying x's, as we learned in the last section, you're adding the exponents. Since they're all to the exponent of 1, this simplifies to x to the 6th. Once again, though, this process is quite complicated, and there's a quick rule when you're multiplying terms that have exponents on the inside and on the outside. In this case, we will multiply the exponents together. X to the power of 2 times 3 simplifies to x to the 6th, which, as we know from this part over here, is the correct answer. So take a second to try this problem on your own. if I see an exponent inside the parentheses and an exponent outside of the parentheses, what do? I multiply them together. So I have 3 to the power of 3 times 4, or 3 to the power of 12. This can be your final answer, but since the base is a number, you can type 3 to the 12th power in your calculator to simplify even further, and it would be 531,441. In this problem, we're being asked to work backwards. Both sides of the equal sign have a base of 2. Where can I simplify? Well, over on the left side of the equation, I have an exponent of x on the inside of the parentheses and a 2 on the outside of the parentheses. And if I multiply them together, 2 times x, the left side of the equation simplifies to 2 to the power of 2x. And that equals 2 to the power of 8. Since the bases are the same, all I need to do is make sure that the exponents are the same for this equal sign to work. So I will set the exponents equal to each other. 2 times x equals 8. Divide by 2 on both sides of the equation, and x equals 4. So there are 2 ways of tackling a problem like this, since I have numerical values inside the parentheses. The first way would be to multiply the terms inside. 4 times 6 is 24 to the 5th power. You can type this in your calculator and get a numerical answer. You could also be asked, however, to simplify this, leaving the numbers inside and just distributing this exponent. So each term inside of the parentheses must be taken to the 5th power. It's sort of like distributing. So this problem will simplify to 4 to the 5th power times 6 to the 5th power. This problem is similar to the last one, except we see division, or a fraction, inside the parentheses rather than multiplication. However, the same concept holds true. Each of the terms inside the parentheses must be taken to the power of 4. So this will simplify to 8 to the power of 4 over 3 to the power of 4. So remember, when we have 2 terms multiplied together inside of the parentheses, 3 times x squared, we have to square each individual term inside the parentheses. So I will write this as 3 squared times x squared. Can we simplify further? Definitely. 3 squared is 9. And since x is a variable, I will leave that as is. 3x squared, 3x parentheses squared, becomes 9x squared. As we know from before, just like with multiplication, when there's division inside the parentheses, or a fraction, we still take both terms to the power of 3, or cubed, x cubed over 2 cubed. X cubed cannot be simplified since I do not have an exact value of x, but 2 cubed, or 2 to the power of 3, equals 8. So here is my simplified answer. Okay, so let's apply the principles that we've already practiced on this problem. Inside the parentheses, we have 3 times y squared. And this will need to be cubed. We distribute the power of 3 to each of these terms. 3 cubed times y squared cubed. Do you remember what to do when there is an exponent inside and an exponent outside of the parentheses? If you said multiply, you are absolutely correct. 3 cubed times y to the power of 2 times 3, or y to the 6th. 3 cubed is 27, and y to the 6th cannot be simplified. So this is the final answer. In this problem, both terms inside the parentheses are taken to an exponent. I will break this apart into 2 different terms and square both of them. Now, as we've been practicing, we multiply the exponents when one is inside and one is outside. X to the power of 4 times 2 times 2 to the power of 3 times 2. Well, 4 times 2 is 8, so that is the exponent of our variable. And 3 times 2 is 6, so that is the exponent for our base of 2. So with division, as with multiplication, we still distribute the cube to each of these terms, which results in 6 squared cubed over 2 cubed cubed. Multiply the exponents. In the top, we have 6 to the power of 2 times 3, or 6 to the 6th power, and in the denominator, 2 to the power of 3 times 3, or 2 to the. So as you can recall, taking a term to an exponent means you're multiplying that term by itself however many times. So our numerator is x times itself 7 times. X cubed, we're only multiplying x by itself 3 times. When simplifying rational expressions, if you have a term on the top and a term on the bottom that are the same, they'll simplify to 1. So I can take 3 x's away from both the numerator and the denominator. How many x's do we have left? Well, there's 4. X times x times x times x is equivalent to x to the 4th. But just as with multiplication, division also has a rule that makes our lives easier. I can write this problem as x to the power of 7 minus 3, or x to the power of 4. What did you do with the exponents? Because this is division, we need to subtract the exponents. So 3 to the power of 6 minus 2 simplifies to 3 to the power of 4. Great job, everyone. This problem also requires working backwards, just as the one we saw when we were working on multiplication. What will the difference be? Well, since I am dividing the terms, instead of adding the exponents, I'm going to subtract them. This becomes 4 to the power of x minus 3. That's equivalent to 4 to the 4th power. And as we saw earlier, since the bases are the same, what we need to do to make both sides of the equal sign equivalent is set the exponents equal to each other. So x minus 3 equals 4. Since 3 is being subtracted here, I need to add it to move it to the other side. X equals 4 plus 3. X equals 4 plus 3, which results in an answer of 7. The final topic we're going to cover in the lesson today involves negative exponents. If I have a term to a negative exponent, I simply move the term to the other part of the fraction, in this case from the numerator to the denominator, and I take away the negative sign. So x to the power of negative 1 is equal to 1 over x. What would change if I made it x to the power of negative 2? I still need to move it to the denominator, take away the negative, but leave the exponent. So x to the power of negative 2 means I move x squared to the denominator of my fraction. Here we see 3 to the power of negative 3. The first thing I'm going to do is move the 3 to the denominator, and then I will change the exponent from negative to positive. If the question asks you to leave the answer in this form, that's fine. Or because 3, the base, is an integer, I can simplify further by taking 3 cubed. So 3 to the power of negative 3 equals 1 over 3 cubed, or 1 over 27. When you see a question like this, they may ask you to rewrite it in the form of 4 to the power of n. Well, this 4 in the denominator is to which power? It's not being multiplied by itself, so it's 1 over 4 to the power of 1. Well, working backwards, I can take this term and move it to the numerator as long as I change the exponent back to a negative. So 1 over 4 equals 4 to the negative first power. And in this case, n would be the exponent, which is negative 1. So here's our final example. Take a couple seconds to see if you can figure out how to rewrite this problem in terms of b to the power of n. So hopefully you decided to move b to the 4th to the numerator, and that means I'm multiplying it by 1. So it's not going to change the coefficient. The only thing that changes is I take my exponent and make it a negative 4. This is the simplified version. If they ask you for n, it equals the exponent, which is negative 4. Thank you so much for taking time to watch this video and taking great notes. Please look on Google Classroom to see the assigned homework that goes along with this lesson. I hope you're all well and have a nice day.